then we will know that okay, why we have to come up with this new requirement. Understand? Similar to the software maintenance, if there is any changes in your software, regardless of the architecture, coding, hardware, okay, the flow, process flow of the software, then you have to record down the changes, those information related to changes. Let's say for example, which part is going to be changed. Okay, previously, okay, how is it looks like, and the new one, how is it looks like. Okay, and then who is the person who performed the changes, who is the person who approved the changes, when the changes is made, okay, and what is the related items that is involved in these changes. You have to record it down. Okay, why? Because if anything happen, then you can trace back, okay, is it these changes, when we come to here, what is the reason. Understand? And then we can know that okay, previously is how is it looks like. Okay, so this is very useful, okay, for us. Why? Because let's say for example, for the codes, okay, let's say for example, we just directly go and amend the code, that's settled, bye bye. Then we do not keep track of the changes and the version also. So in this case, when we are going to how to say, we are going to revert back to the previous changes, we don't know the previous is how is it looks like. Understand? Okay, and sometimes we may need to use back the previous version to do some re-engineering, so do some improvement. That is true also, because why? Sometimes we may find that the previous version may have a better stable, okay, then we can make use of the previous version to modify it. If we do not keep track of this version or the changes, so how are we going to know which version is the previous version? Definitely we will know one. Understand? Especially when we are another example is especially when we are developing a project in which are more 10, for example, 10 developer is creating the same project. Okay, then if without this configuration management, how does others development know that okay, which version is your current editing version? Understand? So to avoid any ambiguous, okay, to allow traceability of the item status. Okay, now look at the goal here. The goal of CM is configuration management. Since we are applying, what we discuss is applying in the software, we call as a software configuration as management, and we call also call as SCM lah. Okay, is to manage and control the numerous correction, extension and adaptation. So this one actually is the changes lah. Okay, that are applied to a system over its lifetime. Once your system is still being used, okay, configuration management is still will be assist. It handles the control of all product items and changes to those items. SCM definitely is applied to the software product. Okay, so to control the document and other artifacts like the delta, the release, the source code, the tools, hardware, okay, or maybe the design, the requirement, everything. Okay, so the test cases, test data. Okay, now this is a more detailed definition or explanation on this configuration management. Is a method, okay, system engineering method that ensures a product attribute remain consistent throughout its life cycle. Yes, why? Because in configuration management, you need to make sure that all the related artifact, okay, is consistent. Means that if we update this one, we make sure that others related document is being updated. Understand? Okay, so configuration management is an IT management technique that tracks individual configuration pieces of an IT system in the realm of technology. Okay, IT system are made up this one only. Okay, because IT system they have, when we create our system we may have different level of granularity understand? So different level of granularity, then we should have the configuration management, okay, used to link or relate to them. Okay, maybe okay, this level of design, let's say software architecture, when this component, okay, the detailed design it is in which page of the design and which version, then here's come the configuration management. Therefore each design you should also have an identifier. Even though every single module you need to have an identifier for them also. so that we can trace and relate. Okay, now come to this one. Definition is the discipline of identifying the configuration of a system at discrete points. Okay, at discrete points in time for the purpose of systematically control changes to this configuration and maintaining the integrity and traceability of this configuration throughout the system life cycle. Identify the item, okay, and control the changes, maintaining the integrity and traceability of the configuration. Okay, so ensure everything is traceable not only the development process, okay, maybe the maintenance process also, okay, and therefore you enhance the quality of the delivery system and the productivity of the maintenance. Why? Because everything is very clear stated, understand, and all the state of the item is determined. It's determined so that okay, the developer will not use the wrong thing, understand, and then they will not spend lots of time to find the actual which one is the suitable one. Okay, so therefore this is the one of the benefit of configuration management. One of the activity is versioning. Keep track of the version. Okay, definitely there is a unique identifier to represent each of the version. Okay, why? Because same reason and how to say maintain the integrity and the traceability of the item. Okay, this is the benefit. Confusion is reduced and order is established. We know which one is come first, which one is the latest one. Avoid confusion. Yes, everything is very clear. All the status of item is very clear. Okay, allow us to evaluate, approve and implement changes into a configuration item in and we can evaluate it, okay, whether we can approve it, whether to change or not, okay, or maybe allow us to track the changes or implement and track the changes. Okay, to maintain product integrity, definitely okay, because all the things is organized, the process is organized, activity is organized. Correct product configuration are ensure, avoid ambiguous. Okay, avoid ambiguity. Okay, quality is ensure. This is another benefit. Cost saving, for example. Okay, so throughout the development cycle, because it's able to track, you don't need to spend a lot of effort to track, to audit, to check for the correct item. Okay, a reliable working environment is provided. For example, like those like your GitHub. Okay, so you have a reliable environment. Let's say for example, programmer is located in an isolated workspace to do his own work without affecting the actual one. After done already, confirm already, then he can publish and affect the main actual one. Okay, so compliance with standard. Yes, accounting of status is enhanced. Yes, accounting of status means that they provide a history of the status, change status of the item. Then you can trace back what is the changes so far, how the changes direction is. So this is the accounting of status. Now there are 4 elements of CM. What are the 4 elements? Identify the configuration. Definitely this is to describe all the necessary artifact involved in the project. Achieve the baseline. Okay, achieve the baseline. Okay, and the changes to the artifact. Control the software configuration means that you need to monitor and control how the changes of the configuration. Okay, how the changes should be changed. How to determine whether one change is it considered as a next version or does not consider as a next version, or maybe just an update only. So you have to determine it. Auditing software configuration, this one is make sure that all the status of the item is visible, and make sure that any changes is meeting what is expected and meeting the requirement. Okay. Accounting software, just now I said, this one is provide a history. Okay, change history or administrative history. Change history lah. Okay, how the changes is made so far. Okay, so that you can trace back. Come to another topic. Need to slow down a bit. Okay, so technical dimension, SCM. So you can see that the SCM functionalities, okay, can be applied into 3 technical dimensions: product, tools, process. Okay, product. Okay, when we apply product means that we identify the product. Allow us to identify the product. Version control of the product. System models and selection. Then in this case, we should have a certain model to support the configuration management. Okay, what are the models? Actually, it can be a standard lah. Okay, so number 2, under the dimension of tools, okay, workspace control means that maybe he provide a space, a share folder or share directory for us to freely amend the code. Maybe, okay, this software configuration provide a function like, let's say for example, how are we going to handle the release building? Okay, means that allow us to create executable file from the changes and allow us to create the delta and allow this delta or the binary version file can be deployed, safely deployed one. Okay, these are some functionalities in the building. And then the last one is the isolated workspace. I'm in here. Okay, isolated workspace actually is a local workspace for the individual programmer. Okay, then come to this here building again. This building actually is more on the release management. Okay, release management, how to make sure the release, okay, can be compiled into a binary code and make sure all the release is safe. Okay, and then identify the release. Process, change management, help in change management. Okay, track, control the change, how the change is being performed. Status accounting, okay, provide a history of change. Okay, editing, okay, allow us to make sure the change is fulfill the requirement. Okay, so this is my brief description on here lah. Okay, now we slowly go into one by one. Okay. What is this? Identification. This is under the product dimension. Okay. These functions identify those items whose configuration must be maintained. Yeah. Means you need to know, okay, what are the items involved in this software. The building of this software throughout its product life cycle. For example, requirement specification, design, data, any diagram, okay, source code, executable code, tools, test script, test plan, hardware, software, anything lah, understand? Inclusive of the compilers, interpreters, emulators, and so on and so on. Okay, so in this case, it means that you not only identify them, you need to achieve a baseline. Okay, you need to achieve a baseline. Okay, describe that. Okay, at this particular time point, what is the status of this item? Okay, now version control. This function also in the product dimension. Okay, product dimension. Version control. I guess we all know what is version control already, right? Okay, by going through our practical file. Okay, so anyone do not know what is version control? Manfong, yes, what is version control? Yes, your friend, you see your friend say, who are you? That is friend. Okay, so yes. Oh, okay. Yes, Manfong, what is version control? Control the version. Okay. Correct, Version control is to control version lah, correct lah. Okay. So maybe I ask someone else. Okay. So maybe when Feng say, "Ayah, Mr. Lim, so easy question you want to ask me ah?" Okay. So now any student can help. How about I want to call someone else ah? I always forgot to call the student one. Who? Junhing ah? Not you. Okay. No. Who should I ask Xin Yi. Is Xin Yi here? Where's Xin Yi ah? Xin Yi. Where's Xin Yi ah? Is Xin Yi here? Where is Xin Yi friends? Yes, Xin Yi. Yes? No Xin Yi is not here, man. I guess Xin Yi is here lah. It's in the venue, yes. Yes, Xin Yi. Raise your hand. Who is Xin Yi? Not here ah? Really ah? Really? Then, Feng Ji eh? Yes, where is Feng Qi? Yes, yes, Feng Qi. Yes, where's version control? Group 7. Yes, Group 7 is here. Feng Qi, yes. What is version control? Wait, how come I guess most of you already experienced using GitHub on the previous semester already, right? Okay. Yes, what is version control? Some sort like that lah. Okay. So actually version control is a function, okay, where we store your not necessarily source code, actually document also can have version control one. Okay. So when there is a changes, okay, maybe we need to identify that a number that shows that the difference of this copy with the previous copy. Understand? Sometimes we can use the version number to represent it. But however, certain amendment may be too small already. It's not considered to use as a new version, so maybe they use another way to show the differences. Understand? So they will show that before changes, after changes, and future changes, whatever lah. Okay, they will keep track, allow us to see that how is the change looks like, and then they control. Okay, they identify which version maybe is a stable one, which version is a description that maybe it's an alpha release or a beta release, some sort like that lah. Okay, so this is the version control, and also allow us to revert back to the previous version also. Understand? Okay, allow us to simply generate the pick one version can allow us to generate to a binary code which can be installed one. Okay, so this is version control. You can see that the explanation here. Okay, every time the artifact is modified, a new identifier is assigned to the artifact to minimize confusion during the evolution process. It means that identify the changes. Understand? Okay? So it's worth nothing to give each alteration of the same artifact a new identification. As I said, not necessarily all the changes but lead to a new version one. You have to decide. Understand? Okay? So whether how are you going to differentiate these changes? Okay? System model and selection. This one. I have added extra line here, class. This one. This one. Okay. So requirement, specification, test case. Okay. Those artifact items involved. Then you should have determine, well define them. Okay, and store them in a distinct files. Okay, so the requirement for this artifact develops, okay, so that the maintenance employee can link them together. But definitely in software configuration management, sometimes you need to apply a models. Okay, models here maybe you can refer to a standard lah. Okay, that used to support the concept of software configuration. Maybe your software configuration, you apply the standard, okay, that follow certain standard to perform the software configuration management. Let's say for example, the models or the standard, these are the example. Okay, IEEE 828-2012, CMMI, DEB, ISO 10007, 2003, and ISO IEC 15504. Okay, some of this example of the standard that we can use to support the concept of software configuration management. Okay. Now, just now we say configuration, we always say configuration. What is a configuration? Now look at this one. It's a collection of versionable elements. Configuration. Okay. It's a collection of versionable elements. Okay. Continue. This model selection, version control and identification actually is the functionalities of SCM on the product dimension. Okay. Now we come to the workspace. Okay, dimension is called workspace. Okay. So under this dimension we have workspace control. Okay. Either we can provide isolated workspace to the programmer or user to do their coding or works, okay, or sometimes we may have a shared directory for everyone to access and so on. Understand? So this is referring to the workspace control, and definitely this control, okay, is you can see that here, realize a workspace in two ways. Okay, might be a basic programmer home directory while modify the files, or it can be a more complex system like integrated development environment. That definitely your Visual Studio, NetBeans, okay, that one is also considered a workspace. Am I right? Okay, the space you create the program, isn't it? Okay, so in this case, either you can create in your own local computer, or either if you are accessing the GitHub, okay, so through Visual Studio or NetBeans, then you can share the coding. Am I right? Have a common share folder. Okay, so this is the functions provided by SCM in the dimension of workspace. Understand? You can see that there are three functions. This is, I said, sandbox is a share folder or share directory where all the programmers or developer concerned can go and modify the code freely. Okay, building is more on building up different delta, different version. Okay, allow us to build. When we create some changes, we commit the changes. From the changes there, we can build the binary code. Understand? We can build the binary code. Okay, so isolation is like your own individual local workspace. Okay, so these are the three functions. Understand? And this building and this building is a bit different. This building is on the workspace, okay, on the function of workspace. This building almost is a similar, means that this one is allowed the build of different version, okay, for to deliver the system. Maybe you can select the older version and convert it, build it into binary file, and can be deployed one. Understand? Okay. So, and then definitely this SCM, okay, system is able to support this function building. Understand? Okay, it's almost similar with this one, this building. Okay, now change management. This is on the process dimension. Okay, when we talk about the process, okay, then when the system is there is a changes. Okay, how are we going to control and manage the change? That's why here come of the process of change management. SCM support or provide change management for the change process. Okay, so The SCM must enable user to understand the impact of the modification. Okay? Must allow user to know what is the effect of the change. Okay? Allow the user to identify which part of the system need to be changed, and provide the tools, okay, to manage the change. Understand? Okay? So these are the SCM functions that apply in change management. Status accounting, this one is to keep all the necessary record okay, for all configuration, okay, and to process or produce a history of change report, okay, to show that, okay, how the change evolve. Okay, so what is the history record, or what is the record describe? Describe the product correctly, used to verify the configuration of the system for testing and delivery, maintain a history of change requests. CR stand for change request, including both approved one and the reject one. Okay, so this is the status accounting. The next one is auditing. Auditing is actually, when you talk about auditing, means that we always check and evaluate lah. Okay, so to ensure that, okay, you will know that, okay, who is the one who make the changes. Okay, what are the changes has been made. Okay, why they need, what is the reason to apply these changes. Understand? Okay, and then after the change, you need to, this auditing allow us to trace back whether these changes is what we need to change or not. Understand? Okay, so under this auditing, okay, there are two kinds of auditing. Okay, before the new release is published. Audit for functional configuration. Check the software whether it satisfies the system requirement. Another one is audit for the physical configuration. Check whether, okay, check whether the program is appropriately represented in the reference and design documentation. Whether all the documentation is updated, is it consistent or not? Understand? Okay? That's it. These are the three dimensions. Now we come to another topic. Very fast. Do you need a break? Okay. So, 4:38 only leh. Okay. Another 5 slide. Short break lah. Okay, short break lah. Okay, we take 5 minutes break lah. Okay. Okay, shall we continue, class? Hopefully we can complete this subject, this chapter, and start with another new one. Hopefully. So now we continue. This diagram shows the process of SCM. You can see that for this process, there are 3 layers. Okay, so or 3 different levels. Okay, for the first round, okay, the phase here. Now is the plan SCM program. Before you want to apply the SCM, you have to plan it. What are the activities or process inside here? Define the process. Define the process means that you have to determine what is the strategy you're going to use. Okay, how you conduct the SCM. Then after that you have to identify the stakeholder. Then develop, or maybe you need to purchase the tools to support your SCM task. Understand? So once you have planned everything already, then you come to establish baseline. Means that you have to identify those items to be controlled. Okay, so identify the baseline, develop the schema. I mean the schema or identifier means that you have to set the format or the structure of the ID, understand, the identifier. After that, this one everything set up already. Then now if there is any changes applied to the artifact or items, you will go through this process, evaluate the change, how is the impact, what is the effect, okay, and then decide go or no go, okay. Then track the changes. During the process of change, you have to monitor and track every changes which are made, okay. So and then update the necessary document history, okay, produce a report for the change, and then at last audit, check whether all the necessary document is consistent or not. With update, is it the change is comply or achieve or meet the requirement or not, okay. So if another round of changes come to here again and again, so this is the SCM process, okay. You can see that again, I want to speak. Establishing a baseline, okay. So means that this is the first I start with here, establish the baseline. This one, start with here, okay. So establish baseline. To find out if something is subject to configuration management, identify the item, okay. So establish the baseline. Establish the baseline, okay. Store this item or record this item in a library, and then after that, okay, you have to what we call decide the schema of the identifier, okay. So this is the under establishing baseline. Now these are the activity in the baseline process, means in here, in this one, okay. These are the okay in here in the second layer. So what are the activities? For example, create a snapshot for the current version, okay. Check the configuration and assign the version number to the item, okay. Store the approved authority information as metadata. Information should be distributed to all stakeholders, means visible to all stakeholders, okay. Create a schema of words. This is to create the identifier lah, okay. And then what else? Create a schema of word, number or letters for common sort of configuration object. Okay. Furthermore, particular what is it? See the word. Nomenclature may be required by project needs. What is this one? Nomenclature. Is it? It's a what? What is it referred to here? Nomenclature. So terminology lah, jargon lah, understand? Okay. So this is the meaning here. So and then come to this is the control the change of the configuration, the third layer, the third phase, okay. So when you have after you have achieved the baseline, when you have the change that is need to perform, then you have to control the changes, okay. So in certain interval, okay, you need to check audit, okay, to make sure that that is the changes is meet the requirement, the configuration is correct, okay, and then all change activity is recorded and up to date. So this is during the control process, okay. That's it, finish. Chapter 5 done already. Any questions? Any questions? No. Okay. So any questions, class? Hey, don't pack your thing first. Okay. We may need to continue with chapter 6. Yeah. Okay. This is a very interesting topic compared to chapter 5. Okay. We take 5 minutes. Okay, at least let me finish until slide what? Slide 10. Slide 10. Very fast one. Okay, don't worry. I will hold you long here. Yeah. Okay. So any question in the configuration management class? Nigel, any question? Group 5. Chapter 5. Any question? No. Then Christopher? No. Yes, group 5 still got who? Ekan. Yes, Ekan. Ekan. Any question? Chapter 5? No, Okay, okay, now we come to another new topic. Okay, we cover 10 slides. This is all the introductory, okay? Now, so far, what you learn is software engineering, okay? You build a software from scratch, am I right? From scratch. So, when you build a software from scratch until you deliver a software, okay, this is also referred as a forward engineering. But however, during the software maintenance, or sometimes there may happen issue when we need to so-called re-engineer the software. What I mean by re-engineer the software? So that's why they come in this term software re-engineering. What I mean by software re-engineering is you build a new system, okay, from the old system. Okay, you build a new system from the old system. So how do you do that? Definitely, first thing you have to study the new system, the old system first, Am I right? You have to understand the old system. Then somehow you may need to modify perform some modification, and then to derive the so-called new system. So this process, okay, is called software re-engineering. Okay. So what is the goal? Okay, to understand the system. Okay, to improve the functionality and quality of the system. Sometimes when your system does not have any clear documentation, or maybe the system is too old already, or maybe the system, the person who knows the system already run away or no longer there already. So therefore, in order to have improve the system, sometimes you need to re-engineer the system. Means that you create a new one based on a old one. Understand? So somehow re-engineering also can be considered as part of the software modernization. Okay? Modernization. We modernize the software. Normally this software is a legacy one, okay? We modernize the software. Therefore, engineering can be considered of part or activity of software modernization. Understand? Okay? So now continue. Re-engineering. Definitely when we want to build some new software based on the old one, there is some risk. Sometimes when we build the system based on the old one, the new system may be totally different from the old one. By right should not be like that, am I right? So and then the quality of the new system may be worse than the old one. Okay? The benefit when you create a new system, the benefit is not significant. Understand? It's not significant. Means that you are wasting your money and resources to build to re-engineer the system. Understand? Okay? So there are 4 general objectives in software re-engineering: improving maintainability, migrating to new technology, improving quality, preparing for functional enhancement. So these are the common 4 objectives of software re-engineering. Okay? So now in re-engineering, there are 3 principles involved. One of them is the principle of abstraction. What is meant by principle of abstraction? Means that now when we used to develop a system, we normally use to draw some diagram to represent the system, right? Isn't it? So this representation of a system, okay, will be gradually the detail level of the representation will be gradually decreased. Why gradually decrease according to this principle abstraction? Later we will know of that. Okay. Now look at principle abstraction. The level of abstraction of the representation of a system can be gradually increased. Just now I said decrease I say it's the detail decrease but here they mention is the level of abstraction gradually increase. What is meant by abstraction? Simple, am I right? Okay, not detail. So if the level of abstraction is increased, mean become more simple, become less detail. Understand? Okay. This is what it mean by principle of abstraction. Principle of refinement, the other way around. The level of abstraction will be increased. Means that the detailed representation will be increased. Understand? Okay? So, why I say like that? Now look at this diagram. Actually, this diagram showing the abstraction and refinement. From implementation to conceptual, principle abstraction is applied, is applicable. From conceptual to implementation, principle of refinement is applicable. Okay? So now look at this one, abstraction and refinement. Conceptual level, we know that this is a very high level of representation. Understand? So we always focus on why we need this software. Okay, why we need to build this software. Requirement level is on what the software need to do. What is the function of this software? Understand? So means that this is the high level. This is the level after this one. Then design level, conceptual requirement design. Design level is regarding on what is the structure of the software and how are we going to achieve the functionality. Design SDA, am I right? Okay. Implementation level is only how the system is being implemented. Okay. Now refinement process, which apply the refinement principle. Why, what, and how. Why, how to know why is this one? Now refinement. Why, what and why? Am I right? What and how? Understand? So therefore you come to here. Abstraction process start with how first. How? Okay. What and how? Why and why? Understand? What and why? So you can see that. How? What and how? What and why? Understand? Okay, that is showing in the diagram here. Principle of alteration means that we change the we change the system, representation, but it does not affect the higher level representation of the system. Okay, so it does not affect the level of abstraction in the not high level. Sorry, we made some changes on the system, but however, it does not affect the abstraction level of the system. Understand? Okay, so this is the alteration, not high level. Sorry, okay, I made mistake. Now, why like that one? Okay, then what is the principle? What is the relationship between this principle to the re-engineering? Look at this general model, then you know already. This general model shows that the general model of software re-engineering. When we want to build a new system based on the existing system, first we study the existing system. When we study the existing system, this is called the reverse engineering. Reverse engineering from the implementation, derive the representation for the code, representation for the design, requirement and conceptual, reverse engineering. Therefore, the representation when we derive is becoming more high level. So therefore, this is the abstraction principle applied. When after we derive the existing system, we know and understand the existing system, we may need to make certain changes, alteration. Understand? And then from the alteration, we proceed to build the new system from conceptual down to the coding, right? Isn't it? So this is applying the refinement principle. Understand? And these are the possible changes. For conceptual, we think when we understand this system, old system, in the conceptual level, but before we want to do the new system, then we think of that. What is the purpose of this new system? Why we need this system? Is it the new system? The purpose is same with the old one. Okay. For requirement, we may need to re-specify the requirement. For the design, we may need to redesign, and some similarly implement, we may need to recode. Understand? So therefore, this is the general model that describes the process of software re-engineering. Reverse engineering plus changes plus forward engineering. Reverse engineering definitely from a lower level back to a high level. Forward engineering high level back to lower level. Understand? Okay? So this is what we call software re-engineering. Understand? Can ah? Yes, Chi Chun. Can. Okay, so everyone, any questions? Anyone, any questions? No questions. Okay, so if no questions, then that's it. We continue next week. Okay, of slide 11.